In general relativity, so Einstein's, I should say what it is, Einstein's theory of general relativity is our best theory of space and time. And so it really is, as we talked about before, it's you imagine space and time as a sheet. Just imagine it as a thing, sort of literally a sheet, a surface. And all the theory says is that if you put matter and or energy into that, then it curves it and distorts it, and it can stretch it and make it shrink. And so it's the response of space and time to matter and energy. So the simplest version would be the sun. So you put a big spherical ball of stuff in there, and it warps space and time such that the nice straight lines, something just travelling, minding its own business through that warp space, turns into an orbit. Okay. So light bends around the sun because it's just travelling through the curved space. The Earth goes round the sun because it's just rolling, minding its own business through the curved space. So an example would be, you might say, well, how does curved space, can that give rise to something that looks like a force, which is gravity? So the best analogy I know of is to think of walking around on the surface of the Earth. So if you stand on the equator of the Earth, and you with your friend, and you say, we're going to walk due north. So we're going to set off, let's say we're 1,000 miles apart on the equator, and we're going to walk due north. And what's going to happen? So you walk in straight lines, you don't change direction, you don't do any accelerating, but the straight lines are the lines of longitude on the surface of the Earth. So as you go further and further north, you get closer and closer together. And if you carry on to the pole, you bump into each other. But nothing's happened. And there's no forces acting, it's just that you're moving on a curved surface. And so you get closer. And that's basically Einstein's theory of general relativity. And you can do it. So you can write down that geometry. It's called a warp drive geometry, I think it's called. It's in textbooks. So you can do that to have a warp drive. The question becomes, what sort of stuff would you have to actually put into the real universe to make it warp in that way? And it usually turns out that it's the kind of stuff that doesn't exist, right? But it has properties. It's sort of matter or sort of energy that has properties that do not exist in nature as far as we can tell. Yeah. So the geometry exists. So you can do it, and you can do the calculations, and you can see the warp drive. You can construct wormholes that connect distant regions of the universe, which you could use as time machines. You can do all that in the theory, but in nature, you'd have to have the right stuff to do it. It's a debate, ultimately. So wormholes are a good example. So that would be, quite literally, we talked about the surface of the Earth. So you fly to Australia from LA, and you have to go quite a long way around the edge of the Earth. Or you could tunnel straight through and get there quicker, right? So the first question is, can you make it? And as we've said, we don't think that stuff exists. If you had a wormhole, then what would happen if you tried to travel through it? And what seems to happen is that they become unstable the moment that anything tries to go through. So you get kind of a feedback of stuff going through and through and through and through, and so it collapses. The answer is we don't fully know, but most physicists think that even if they existed, they would be unstable. And as soon as you even tried to transmit information through them, send a bit of light through, then there would be this sort of feedback and they'd collapse. And ultimately, the reason we don't really know absolutely is because you need what's called a quantum theory of gravity, and we don't have one. So we don't have the theoretical tools to be absolutely sure that these things would be unstable or don't exist in nature. But we strongly suspect that they don't. If they did, you could build a time machine. So that can be if you think about something like a black hole, that can be a massive difference in gravitational pull from your head to your feet, and so it can stretch you out. And so, but you can with wormholes, you can write the geometry down in Einstein's theory such that you could go through. So you don't have to be destroyed or anything weird happen to you.